Hello everyone, welcome back to another video. In this project I will be talking about fine-tuning the TinyLlama model. So before getting to the project, let's talk about what is fine-tuning and what is TinyLlama. TinyLlama is a smart AI model like ChatGPT but lighter. It's trained to understand and like a human because it's small and you can run it on the laptop. And fine-tuning is like teaching the model a new skills. For example, there is one TinyLlama which is a smart student and you want him to learn some specific skills. So you need to have a special training for that, which is known as fine-tuning. So basically in this project I built an intelligent travel assistant system by fine-tuning TinyLlama model using the dataset of travel related conversation. The goal was to customize a pre-trained language model so that it could be better understand user query and response appropriately within the context of travel, including the identifying intent and generating relevant assistant responses. So basically I will be talking about the whole project in 5 different steps. So in the very first step, which is a model and tokenizer initialization, I started by choosing TinyLlama 1.1b chat v0.1 model for Hugging Face. So if you don't know about a Hugging Face, it's like a GitHub for AI. It's a website and a platform where developers and researchers share AI models, datasets, and tools so the other can improve their skills. So in this we are using the Hugging Face. This is a small and efficient open source language ideal for training the task. So to load the model I use auto model for cause LLM, as you can see here, class, and also initialize the tokenizer with auto tokenizer dot from pre-trained. I set the tokenizer padding token to match the end of sequence token, since it's a casual language model. So in the second step, which is dataset loading and processing, next I used the ByteX travel LLM chatbot dataset. This dataset consists of 3 different columns. The first one is instruction, intent, and response. The instruction is which is the user query, intent which indicate what the user want to do, and the response which is what the assistant should say. Okay, so to appear the dataset for fine-tuning, I created a column called conversation. This combines all 3 fields as you can see here in a structure format like this. So in the third step, which is LoRa and fine-tuning configuration, so basically LoRa is low rank adaptation which allow us fine-tuning only a small number of parameters. This makes the process much faster and less memory intensive. I set up the LoraConfig with r is equal to 12, dropout which is of 0.05, and the target module for Q project and V project. Then I defined the set config for supervised fine-tuning. I specified the conversation as the dataset, text field, batch size which is 1, learning rate which is 1E4, and the maximum training set which is 1. So basically, as you know that the fine-tuning is like a setting file that tell the trainer how to fine-tune your model. And the fourth step is training with the model, dataset LoraConfig and SFTTrainer ready to initialize the SFTTrainer and .train. So to start the fine training process, since this was the demonstration. I limited just to I trained the setup, but the process is scalable for large data set and training in trains. So if I talk about a little bit about what is SFT training. SFT training means a question and you are giving the correct answer. So it's like you are teaching your model what to do and how you are supposed to respond. So in the final step, which is generating a response, so in this one I provided a query which is I'm trying to book a flight. The model then generate a response which includes both the predict, intent and assistant response. So as you can see here, in the end we are getting the output as an assistant is predicating the required or expected answer, just like a human. So if I conclude this whole project, I tuned the TinyLlama model using the custom travel dataset, applied LoraConfig for efficient training, and successful build a small but intelligent travel assistant system. This approach can be scaled further to build domain-specific chatbot using open source model. So that was it for the whole project, and thank you for watching.